gentlemen, repetitio est mater studiorum, as Aristotle said in Greek, of course, because he didn't know Latin. I don't mean by that, pardon, or English. I don't mean that I will repeat everything. Just three minor, I should say, minor points. We said about the classification of masses in the first lesson, and what else? Where they are formed in areas of high pressure because air stays longer there, and we saw the kinds of fronts. If you remember, in the vertical section of a cold front, which is the ground always, and the cold front, we said it is cold air displacing and replacing warmer air here, but in reality there's friction of any air mass with the ground, of course, and due to this friction, which happens within the friction layer at the first 2,000, 3,000 feet, depends on the ground. In Manhattan, the friction layer is 10,000 feet, but over the sea, it's a few hundred of feet. Anyway, due to the friction with the ground, the form which takes a vertical section of a cold front is more like that. The frontal surface, the front actually is this point at the vertical section. This is the frontal surface, which bends, which takes this curved shape due to friction with the earth. And as you understand, with the surface anyway, and as you understand, this edge here, the front, the leading edge of a cold front, creates a very unstable condition because air here is warm, just a little bit higher is colder, here is again warm.
When you say leading, you mean the penetrating?
The leading edge, the penetrating edge, well, yes. And this unstable condition, depending always of the temperature and humidity on the ground, and at any level, and let's say on the ground first, produces or does not produce precipitation and other weather phenomena. So we have possibly clouds and everything, any precipitation form at the leading edge of a cold front. That was my first point that I repeated just once more for Stathis. A cold front, Stathis, is not like that when it proceeds from west to east, but due to friction with the earth, it becomes curved like that. And this produces a very unstable situation with possibly phenomena. The second point is that continents, land in general, is hotter in the summer and is very hot in the summer actually, hotter than the sea, and colder in winter. Whereas the temperature variations over the sea, in the sea and over the sea consequently, are very much milder than in Earth. This is a matter of thermoporticotis, thermal capacity. And for this reason, the maritime air mass is colder in the summer and it is warmer in the winter. That makes some difference. Maritime air is always colder, cooler if you like, cooler than continental air in the summer and vice versa in the winter. That was the second point. And the third one, we saw about the bend of the isobars of any front, cold or warm, around the form, the isobars, if it is always referring to the northern hemisphere. This is the area of the lows, the area of the highs, the isobars, let's say 100, 1600. You remember these units? What is Costa?
SPH.
No, these units are, well, hectopascal anyway.
Or
Well,
millibars.
this band,
Or millibars.
used to be millibars some
Yeah,
6,
now
7
it's
years ago.
hectopascals, yeah.
Well, this band is always present. Always, the band is present. And we, if you remember, we make that explanation. We made that explanation with a straight line, but it is not our point. My point now, I mean. The point is that, however sharp or not sharp the bend is the tension is always that in front of the front, ahead of the front, the pressure lowers, and behind of the front the pressure always rises. I'm repeating that because due to shortage of time, in my first presentation, I've showed you even such forms. That means that as it is progressing, the front, I mean, and everything, the front, and yes, the front progressing, passing over land over the surface anyway, the pressure along this isobar is steady. It is steady, but before the front, the pressure was falling. I mean, even if the pressure keeps steady after the passage of the front, the general tension is that it is either steady or it falls before the front, and it is either steady or it rises after the front. But anyway, the tension is of this kind, in general, even if it is steady ahead or before the front. And let's take a very small consolidation problem. According to what we said the other time, the wind flows like that, a little bit looking to the lower pressure. Yes, to the low. Well, right. Looking to the low, so that if a plane suppose first that this is a plane, which is not very obvious. Anyway, if the plane is westbound and it penetrates the front, due to that, we called it veering. Yes, the veering of the wind. The plane, in order to maintain same track, it must turn right or left.
Left.
Let's see.
With the direction of the wind, because as it is now,
he's maintaining this track for the time being.
Right.
This track.
Has a right drift. Has to turn to the left.
After the front.
Yeah. The plane penetrates the front.
Yes.
Right.
How thick can we consider the front?
The front is some hundreds or some thousands, not of miles, of feet.
Yeah.
We consider it well.
Quite
After the front, you mean?
After the front, yes, definitely.
It turns right.
He must turn right or left to maintain track.
That's while penetrating.
Let's isolate the wind. The wind first is like that, and it becomes like that. So the wind turns to the right, correct? Correct? Or not? Yes. I mean, here the wind is like that, or if you like, ahead and behind.
Yes.
Well, so the pilot must turn right to maintain track, because as he flies this way, he has the wind from his left. Okay, here he has a wind almost headwind. Okay, because probably in order to maintain this track, probably his heading was like that, probably. But now that he has a headwind, if he does not correct to the right, he will lose his track. Okay, that's an application.
Oh yes. Yeah, but it was not that very.
It's not obvious.
No, it is clear.
It is obvious if you think it over a little bit.
The airplane was drawn in such a way that it was confusing.
Yeah,
You should have drawn the airplane
really?
facing
On the front. It was facing the front. No, on the force to be expressed in the front.
It was not facing the direction of the wind.
Anyway, you can think of it in alternative one.
Όχι, όταν
The sketch
επειδή έχει δεξιό list, πρέπει να κάνει left, αριστερή στροφή. Και μετά θα κάνει δεξιά για να το ισιώσει.
The configuration of the problem is either this one. This is a bird actually. Or this one, if you like. You can think it over at home. Well, and since scripta manent, a consolidation, no, it's not test actually. It's a written summary of lesson number 1 actually. If we don't finish lesson number 1, there will not be lesson number 2. So in the second part we see the formation, the growth and the decay of a frontal depression, which means of a depression which is associated with the front. And I made a mention in my first lesson that at temperate latitudes, such as European latitudes, the frontal depressions are the most vigorous of them all. The most important depressions form at fronts. They are formated, they are generated at fronts. So, let's see what happens. And when I say let's see what happens, it is not only a matter of speaking, because to explain everything, not only I cannot do it, but according to the books, due to the very big scale of phenomena, an explanation is not always possible, not always feasible. Starting with a stationary or a quasi-stationary front, which is the same, of the northern hemisphere, always of the northern hemisphere, and that is why cold air is to the north and the warmer air is to the south, and the prevailing wind is a westerly wind, blowing from the west to east, from west to east. We see at the initial stage stationary front. For some reason, a stationary front is something like that. This is the frontal surface. For some reason, an initial oscillation, talandosi, oscillation, begins somewhere here. On the ground, on the ground, due to some obstacle. And this oscillation is horizontal, talking about, not about vertical movement of the air, but about an oscillation and movement along the horizontal sense. So, a kima, a wave, exactly, a wave. A wave or an oscillation is initiated at the front, so that warm air forms a bulge, forms an edge, into the cold air. This is the warm air, it forms a bulge, Bravo uniform Lima Golf Echo, into the cold air. At the tip of this bulge, well, stages 1, 2, stage number 3, at the tip of the bulge. And let's not forget that the whole system is always moving from west to east. So these several stages are not referring to the same place of the surface. It is always moving. At the tip of the edge, the pressure begins to fall, to drop the pressure, and there's a low created. There's a low created, an area of low barometric pressure, which low, as the system, we're still at stage number 3, which low deepens. The pressure continues to fall further and further. So originally the stationary form became, we had originally a stationary form which becomes a bit distorted, it becomes more distorted, and if you remember the configuration, it ceases in this stage, in some stage, let's call it stage number 3, it ceases to be anymore a stationary front. Is it confusing or what? No. And it splits into two fronts, one cold, one warm. It splits into two fronts. Well, if this was the frontal surface, it bends. Like that, it bends, and one front is chasing the other. Well, the front splits into two, and since the cold fronts are faster than the warm ones, actually, warm front statistically has its speed is only the 2/3, more or less, of course, more or less, the 2/3 of the speed of a cold front. So the cold front catches up. So many things happen at the same time. The whole system moves to the east. The barometric low deepens. Barometric pressure lows. The cold front catches up the warm front. Now, what happens at what is this sector? This sector is probably its original position was to the south, so it consists of warm air. But as the cold front squeezes, catching up,
Temperature increases.
the temperature, despite of what the temperature does, the warm air from the surface is forced upwards, probably, because otherwise it would be forced downwards, which is impossible. The cold front pushes the air from the surface. We see the warm air is forced to upward motion and probably precipitation, but that is not our point. The point is the life circle of this situation of frontal depression. So what becomes of it at the end? At the end, as you see, the cold front catching the warm one, they merge into a composite front, which dies away and is absorbed by some other neighboring system. Again, a stationary front, due to some original wave, some original oscillation, starts to oscillate, is split into two fronts of different speeds. The cold front is catching up, they are both moving eastward. The cold front is catching up the warm front. It displaces the warm air of the so-called warm sector from the surface. The warm air from the surface is going up. The warm sector is annihilated. Finally, the warm sector disappears at all. The two fronts merge, right? A composite front is partially formed, and the whole procedure dies away. This enclosure of the warm sector, in other words, of the warm air at the surface, between two fronts. It's not that easy. Usually it is at the end of any MET book. Well, this enclosure of the warm air, which is included between two fronts, chasing each other, and each other, of course, the cold one catches the warm, is called an occlusion. Occlusion means, in Greek, apoklismos. What exactly is the occlusion? To be precise, the composite front is called an occlusion. The depression, we can say the depression can be called occluded, is said to be occluded, and the whole process is called the occluding process.
When do you have the thunderstorms?
Thunderstorms, well, that depends. These were the configurations, the designs on a surface map, right? Well, its vertical cross section of the whole process must be, well, I have it on a shot, I believe. Yes. Must be like this, the vertical cross section through fronts of a depression. Fronts, I mean through the cold and the warm front. So we have the cold front chasing the warm front, cold air, warm air. The warm sector is being squeezed, minimized, and the warm air is forced upwards. When we have thunderstorms, it depends. Well, if we have thunderstorms, statistically, it's more likely to they are more likely to occur at the cold front, because due to the difference of the slopes of the cold and the warm front, we said the slope is very steep, the bottom is very steep in the cold front, and quite shallower in the warm front. In the warm front, not war sector, warm front. And due to the differences in speed, the horizontal speed of the two, of course, of the two fronts, but it creates, as you anticipated, of course, it creates different vertical speed of the upgoing air. Different vertical speed, different phenomena. So the warm air of the warm sector follows the way up the slope of the warm front and up the slope of the cold front. So depending on temperature, on surface temperature and humidity, we may have, and we usually do, many phenomena which vary, and which the succession of the clouds, for instance, is a very familiar and very favorite question in any MET questionnaire. The succession of the clouds, which means the succession is very various. The formation of the clouds is narrower, in a narrower area here, and more extended here. And that's why, I'm giving you too much, I'm afraid, but I see you're following. And that's why when a warm front approaches, the phenomena start well before the front itself passes through a place, alpha, because the clouds are not in that narrow basis, they're more extended, and if there's rain, could be here, could be 100, 150 miles before the passing of the actual, of the point of the warm front from the surface, because the phenomena do not start with necessarily with the passing of the front. They start with the passing of the frontal surface. Okay, and the clouds on the surface, I've never seen clouds on the surface unless it's fog. Well, let's see if we omitted something. Can anybody tell me why the cold front catches up the warm one? It's faster. Can anybody tell me why, as the whole well, it's faster. As the whole system moves to the east, we said the pressure drops. Why does it drop? I mean, until the whole system dies. But there's a tension of the pressure drop, to go down, of the pressure here on the surface.
What's the block?
Because the air is pushed.
Pardon?
What's the block like?
Possible obstacles.
No.
Because the air is forced up. If the air is forced up, an emptiness. Well, not emptiness actually. Well, the density lowers, and of course the pressure lowers. What else? Yes, and as a classification of occlusions, it all depends whether cold air displaces and replaces cooler air, or vice versa. In the first case, we have a cold occlusion, where the air which pushes the warm sector is colder than the air mass ahead, and vice versa. We have a cold occlusion and a warm occlusion, which I didn't write.
Could you repeat again the definition of an occlusion?
The definition of an occlusion is the process during which frontal depression is occluded, is surrounded and occluded by the cold front, which is chasing the warm front, and both of them come from the split of a stationary front. It's not that easy, I warn you. Well, it's not difficult, but it's a long definition actually. And as a, not summary, because what summary would it be unless I repeat it all? As a conclusion, I would say that this procedure, this process is important because I will remind to you again all the important depressions of the northern hemisphere of the temperate, the temperate zone are formed in the polar front, and that is why in our first lesson I pointed out that the position of the polar front is very important because of this reason. It affects very much the weather in the northern hemisphere. Could anybody? Yes, please.
I had the idea that fronts were formed really at the west coast of the American
some of them,
and they travel along.
Some of them, not all of them.
No?
Not all of them. Some
West
of them.
or east?
Pardon?
The
East Coast. Because we have the general.
Actually,
The general idea that the weather comes from this, from the Atlantic.
yeah.
Well,
It comes from the west.
did I say something that implies the opposite? Well,
No,
but the polar front, is there a polar front in the southern hemisphere? Yes, there is. Yes, there is. But it's not that important because it is mainly over oceans, not so populated areas. Yes, mainly over the ocean. And what else? Your homework. Not the homework, actually, just this. Pardon? Hotel work. No. Ready for any questions that I could answer?
What is a trough they cut down?
A trough.
yeah.
A trough is an area of deep pressure. And a ridge is an area of high pressure. And elongated.
It's not a front.
No. A trough is like an elongated area of low pressure. The ridge
It's a trough
just
line.
the opposite.
It's a trough line.
The trough line, it's produced if you unite the points of the minimum pressure. You get a trough line. Just the opposite is the ridge. The ridge. What other question anyone would arise? No question, not anything. Thank you very much for your attention.
Εσύ το πράγμα το γνώμο.
Ασφαλώς και δεν θα πάει.
Εσύ το πράγμα το γνώμο.